Hello everyone. Now earlier video we have been discussing about what will happen if our STM32 was actually a clone. So in this video we will be fixing the error that will come if by chance our STM32 is actually a clone. So before moving forward with our embedded programming, I would like to take a small step back and verify our board is actually working. This is just my personal ritual stuff that I actually do for every single board. So the reason is to make sure, let's just say if I have completed all the files, I have created the startup, linker, the drivers, I have completed everything, but unfortunately the device is not working properly. So I have to be sure that the board is actually perfectly fine before I do the hardest work. So for this and for only this purpose, we going with our cube ID and we'll be just programming with the hash codes. Now, there are actually three softwares that you are gonna need if you are going to do the test. So, first of all, we need the STM MX, the Cube IDE, and the programmer. So, I have highlighted all the three programs just for you to see these three. So, do mind that I am currently using the Linux mint, so there will be some problems when you're trying to install this program. So, I will create a separate video for you to watch for both Linux and the Windows version. The links will be given in the description below. So, without stretching the video any further, let's get straight into the problem. Now, the first thing we are going to do is to select the microcontroller using the Cube MX. So we will open the CubeMX. Oh yeah, there it is. Now in this, we will select access to MCU selector. It will take some time, by the way. So after some time, this window will pop up, and in this, we have to give the serial number. Let's just say I'm having STM32. From this, we have to select which microcontroller we are going to use. You can actually see that from the chip itself. In my case, I have already selected it and I have put it on my favorite list. So this is the number for our blue pill. We'll have to select it and we will click on start project and we will wait. When we get this particular window, we have to go to system core. In this, we have to select SYS. You have to change the debugger to serial wire. We'll actually see a small change in this preview. This become green. Now, since in my development board, the blue pill, the C13 pin, C13 is actually the onboard LED. So I have to click on PC13 and I have to put it as output. After that, we will go to project manager. We will give a name for our project. We'll just give mm, ABCD. Eh, and we will select the tool chain as STM32 Cube IDE. I will, yeah, this is the directory where I have stored it. You can change it basically using the browse button, and I will just click on the generate code. Now, this will actually take a little bit more time, but let's just wait and see. Now, for the Linux version, I think I have mentioned that there are a lot of bugs and issues that while installation itself I have faced. And to be honest, while running it also, I have faced a lot of issues. So let's just look at this particular problem. I tried opening the project by clicking on the open project, but nothing will come up. What I have to do is I have to go manually and open the cube IDE. So we have the cube IDE here. I will open it. I'll just click on launch and keep everything by as it is in a default position. Oh yeah, now we have the cube IDE. So when we open up, we could actually be seeing something like, oh yeah, before that I have to copy this code. Anyway, this is the test code for blinking the LED. You can just copy it. For now, let's just go for a fresh start. So I will just delete this project. Now we'll go to files. We'll click on create hash import. We'll go down here to import. From here, we have to search the directory where we have actually saved our project file. So where did I save it? STM32. Let me just see that one more time. I think documents. Yeah, got it. In that QT, right? We'll open it. As soon as you do that, you will be able to see a tick mark for the correct file if you have imported it properly. We'll click on the finish button and it is open. Now we will just click on this arrow here. We'll go to core, we'll go to source, main, and we will go for a while loop will be here. And we'll just copy paste the code. If you are unaware where I got this code, I just went down and see it will be here. You just have to copy paste it from here also. It's not that kind of big deal. Now, before doing the build, I will just connect the ST-Link V2 and I will just go and debug. This is the debug button. So if I press it, see 001, and I will just click OK. I think it's because I'm using screen recorder as well. The system is kind of too slow right now. See, the error popped up. Error initializing stealing devices. So what most of you have tried, you might have copied this and went to ChatGPT for help or Gemini, for example, and it might have told you to go to the debug, where is it? Yeah, in debug configuration and try changing. Why is it so? Yeah, in this, it might actually tell you to go and change it to the GDB to open OCD, and maybe it could have also told you to, where is it? Hmm, Yeah, there's actually one more option where it basically tells you how, yeah, this one, connect under reset to system, software system reset. So something like that, it might have actually told you. But there is one more like reply from ChatGPT that actually got me confusing, and that's the moment I realized I'm going on a rabbit hole that doesn't have any end. So I actually the stuff they have told me to do was like at the same time I press the debug buttons, I have to also press the reset on the microcontroller also. So at that moment I realized, okay, there's something wrong with the ChatGPT. I think it's going on a hallucination path. Then all of a sudden, I just stopped all of this and I just went to YouTube. To be honest with you, I just straight up went to YouTube. I did my research for like 3 or 4 hours approximately to get a proper answer. Then itself, I realized, okay, no matter what happens, first and foremost thing I have to do is to create a video on this. No, the solution I have found out is basically close this tab and go to this. We'll right mouse button, go down to properties. This properties we will be going to C and C++. Down there, they will be able to see the settings. And in that, we have to go to this MCU, MPU post build outputs. So we have to check both these, the hex and the binary. We have to click on the apply changes and close. Now, we will again go for the build button. We won't be going for this one, just build it. And the build has been finished successfully. Now we'll just minimize this code. We will go and take the Q programmer. Give it a second, it will pop up eventually. Now, as you can see, the moment I connected my STM32, it is able to detect it. So if I remove it, let's see what will happen. See, debugger not detected. I will again connect it via USB and I will just click on the connect one more time. See, whatever is inside my microcontroller has came here. Now, for us to write into our MCU, we actually need to find where we have actually stored our program. So we'll go back, we'll take the QWERTY. Inside debug, you'll be able to see a hex file. Yeah, this one. We will open it and you click on the download button. File downloaded completely. Now, for this to actually work, like you have to see the output, you have to click on the disconnect and you have to manually press the reset button on your MC. You will be able to see a blinking LED. And that's it. Thanks for watching. From now on, we will be moving straight into embedded firmware engineering.